period of a function. Can anyone tell me what period means?
Sure.
Yeah. It's on the x-axis. Okay, yeah, I totally know what you're saying. Yeah, can you say any more detail?
Yeah, it's the distance between two points that are the same.
Beautiful. Okay, there we go. You guys are all correct. You're absolutely correct. So it's the length of a cycle. So you guys said the exact same thing. It's the distance between where the two starting points. So right here would be considered, you could do it anywhere. Remember, cycles can be made anywhere, but I like to start with x is equal to 0, and then it's back up to the top here. So our period is the length of one cycle, and I like how Dylan says it's the x-axis. So what's the length of the cycle? 4. So our period is equal to 4. And I like how you say it started at the peak and then back up to the peak, so we know that's a cycle. Very good. And then amplitude. What is the amplitude? Amplitude is?
The lowest point and the highest point.
Good. The lowest point and the highest point, the full distance, right? Divided by 2. So if we're at -1 up to 3, what's the full distance? 4. 4. So 4 divided by 2 is 2. So from our midline, it's up 2. From our midline, it's down 2. Okay, good. All right, how many got 100%? Good job. You guys are awesome. Okay, let's get to what we're doing today. Lots to learn. So today we're going to be dealing with angles and the unit circle. Today's a huge day. Now this is trig in secondary 3 is so different than trig you've ever seen before in your whole life. So first of all, you have to understand some vocabulary.
Okay.
Do you have a question?
The amplitude. Yeah.
So we're at -1 up to 3. So the distance from -1 up to 3 would be 4 units, right? From -1 to 0 is 1 unit. From 0 up to 3 is 3 units. So the full length is 4. Yeah. Okay, so you've got to understand some vocabulary before we get started today. So first of all, to make an angle, we're going to be dealing with an XY chart. And to form an angle on that XY chart, you take your initial side. This is called a ray. So you have this ray here. And if you take it and swing it around like this, it's creating an angle. And this is called the terminal side. So where it swings to is called the terminal side. So the initial side is where it initially starts, and then it's curving around to make an angle, which that's then called the terminal side. An angle in standard position just means it starts right here on X. So we're going to be dealing with angles in standard position. All right. So nothing super huge here. Do you guys all see how an angle is made? You see the red dotted line? I'm telling you that's the angle. Okay. So a couple of things you have to understand. You can have positive and negative angles. Positive angles is if you're moving clockwise. So if we have this angle being made here going clockwise, it's positive 120 degrees. Does everybody see how going around this way makes it positive 120 degrees? And then if we were to start here and our terminal side swings down counterclockwise, meaning underneath. So now we have an angle created coming from underneath. So going counterclockwise, that creates a negative angle. So that's negative 120 degrees. So do you see the difference between positive 120 degrees and negative 120 degrees? Because we're going the other way, underneath, for negative. Okay, so we're going to have positive angles and negative angles. They are different. Like you can have a negative and positive angle. Okay, questions on that? So working counterclockwise is negative, clockwise is positive. Okay, so a couple of things to understand, which you should I think you already know this. So this is 0 degrees. From here to here would be 90 degrees. Does everybody understand that? So then from here to here is 180, because that's an additional 90 degrees. Does everybody understand that? So then from here to here is another 90 degrees. So if you add 180 plus 90, you'd get 270. And then from here up to here is a total of 360 degrees. That's why it's a full circle. Does everybody see that? Okay, sweet. So think about it, guys. All the angles in between here will be like, for example, this is angle. You could do it however, you could split it up however you wanted, right? This could be 5, 10, 15, 20, 20, right? Or we could do 20, 40, 60, 8, right? Everybody, do you see how you can split this up many different points? So our angles between 0 to 90 would be angles between 0 and 90. And so on as you go around. Does everybody understand that? So now understand this. What if I went counterclockwise? This would be considered negative 90 degrees. right? So this would be considered, if I'm going counterclockwise, negative 180 degrees. If I go again, this would be negative 270, and if I go to here, that would have been going negative 360. Is everybody good with that? No questions? Okay, awesome. Okay, so now we're going to just be asked, what is the angle? So we're going to have to kind of think critically here on these. So it says, what is the angle? Question mark. So it's giving us a hint here. It's telling us that this distance from here to here is 30. So we've got to think about it. What is the angle? So notice it's going around positive, right? So we know it's a positive angle. So there's many different ways to think about this, you guys. Many different ways. But let's say we went the full amount. Wouldn't it be 180? But we're 30 up from 180, right? So can we go 180 minus 30 to know how far over we went? So 180 minus 30 would be what? 150 degrees. So this angle was 150 degrees. Any questions on that? Okay, just critically thinking. Awesome. Okay, now looking at this one. Once again, it's giving us a hint. It's saying that this is 210 degrees. But notice my arrow's pointing from underneath. So we're going to have a negative angle, right, everybody? So let's think about it. I mean, there's 20 million different ways to think about this. This is kind of how I see this one. You might see it differently. I know a full circle is 360, right? I think about it this way. So then let's do 360 minus 210. Because isn't this piece 210? So wouldn't that give us the leftover? So I'm taking 360 degrees minus 210, which is, so we have 360 minus 210, we get 150 degrees. But this was in the negative direction, right? So negative 150 degrees. Very good. Questions on that? Not really that hard? Okay, sweet. All right, so then last thing that I'm going to let you practice. It says sketch each angle in standard position. So this is positive 95 degrees. So we have our XY chart here. You can draw it in. We know this is 90, right? So 5 more degrees this way would be 95 degrees, right? Now here's how I want you to know that you've done it correct. Be like specific, like give me a hint. Like this is 5 degrees. So that I know you went 95 degrees. Does that make sense, everybody? So I went 5 degrees past 90, and then I just gave you a hint. Do you see what I'm saying? Your hint might be different than somebody else's hint. They could have said that this is 360. Do you get what I'm saying? Your hint might be different than mine. All right, so it says negative 320 degrees. So let's think about this. This would be going, and I can erase this. This is going negative 90, negative 180, negative 270. So how much more do I need to go?
40 or 40 less.
Okay, I like that idea even better. You're saying, okay, so the full circle would have been 360. So then minus 320. So you have 40 degrees, right? Left over up here. Okay, so somewhere up here, 40. We know that would be negative 320. Does everybody see how you're thinking through this? Many different ways to think through. Good. I like that. I like it. Questions on that? Okay, you're set to go then. So do 1 through 11. So now we're going to talk about coterminal angles. So you're going to have to know a lot of vocabulary, which it's not necessarily hard, but if you don't know the vocabulary, then you can't do it. So it says, coterminal angles are 2 angles in standard position that share the same terminal side. So everybody look right here. So we have this line making this positive angle of 135. Here's my terminal side, right? Well, notice the angle negative 225 also hits that same terminal side. Do you see that? So if those 2 angles hit the same terminal side, meaning this line is the same, then they're called coterminal angles. So let's think about it. If we started with positive 135 degrees, wouldn't we be back to the terminal side if we added, starting with 135, if we added 360? Wouldn't that put us right back here? So if we add 360 again, won't we be back there again? Another coterminal angle. So let's do 135 minus, let's go this way, minus 360, wouldn't we be back to here? So So that's how they got that. Do 135 minus 360. What do you get? Negative 225. Do you get how you can do it? So you can add 360 to an angle or subtract 360 to an angle, and it will put you at the same place. Do you understand that? Okay. So it says find the measure of an angle between 0 degrees and 360 degrees, coterminal with each angle. So it says, so we want an angle that's coterminal, that sits in the same place as negative 100. So you don't have to draw a picture, but I'm just putting this in perspective. Wouldn't that be right there, going this way?
Yeah.
Roughly. So let's say, okay, so let's add 360. So let's start here at negative 100 and add 360. Won't that put us back in the same spot?
Yeah.
So that's a coterminal angle. Do negative 100 plus 360. What do you get? 260 degrees. Is that angle between 0 degrees and 360? Yeah, so we can keep it. If not, we would have subtracted 360 or added 360 again. Do you get what I'm saying? So there's our angle. So we could find another coterminal angle. Couldn't we add another 360 to that? Because wouldn't that put us back in the same spot? Or couldn't we have started with negative 100 degrees and went in the negative direction, 360? That would have gave us negative 460, but we want the one between 0 and 360. So number 13, it wants to know a coterminal angle with negative 60. Once again, negative 60 is about right here, right? So a coterminal angle means it starts in that same spot. So you can take negative 60 and add 360 degrees. Go around in a full circle. What angle would that be? 300 degrees. So they're coterminal. They land in the same spot. Isn't that an angle between 0 and 360? You see what I'm saying, everybody? Okay, let's do this one. That's not the only coterminal angle. I could keep adding 360 all day. You get what I'm saying? I could subtract 360 all day. There's a million coterminal angles to every angle. Do you understand that? The only reason we're stopping is because it says it wants the one between 0 and 360. Okay, this one. Yikes, I don't even want to draw it in. It's around more than once, right? So I don't want to draw it in. I know I can add 360 or subtract 360. Because I want the one between 0 and 360, I'm going to subtract 360. So 484 minus 360 degrees. So let's go around in a full circle in the negative direction. Do you get what I'm saying? So 484 minus 360 is 124 degrees. That's a coterminal angle. It's going to land in the same spot as this. Does everybody see how to do this? Sweet. And then number 57 I'm going to do with you really quick. So it says, find a positive and a negative coterminal angle for the given angles. So a positive one and a negative one. Yours might be different than your neighbor's as long as you have one positive, one negative. So you can do this a couple different ways. Can't I take negative 680 and add 360? Okay, so I'm going to do that. Negative 680 plus 360. I get negative 320 degrees. It's coterminal and it's negative, right? So there's one of my answers. I need one that's positive. Well, I can add 360 again. Let's go around in another circle in the positive direction. So I'm going to add 360 and you get 40 degrees. Isn't that a positive coterminal angle? So positive 40 is going to land on the same spot as negative 680. Do you see what I'm doing here? Okay, awesome. So do these problems. Then we'll get to the good stuff. So we have a question on number 55, which is 50 degrees. So we want to find coterminal angles, two. So let's think about where would 50 degrees be? About right there, right? So let's think about it. Starting here, this is the negative direction, right? So let's take 50 and subtract 360. That'll put us back there. That's a coterminal angle. So 50 minus 360 is negative 310 degrees.
Yeah.
So that right there is negative 310 degrees. Do you understand that? Okay, then also, we could say, okay, we're starting at 50 and let's make a positive coterminal angle. So this time let's add 360. So that would be going this way, right? So 50 plus 360 is 410. We now have a positive coterminal angle and a negative. Yeah.
What about 58?
So you have 395. And we want to know what's a what's a positive coterminal angle, what's a negative. So 395 minus 360. What do you get? 35 degrees. Is that negative? No, but isn't that in the same spot? 35 degrees. So I'm going to take 35 degrees and subtract 360 again, and I get negative 325 degrees. Do you see how I just subtracted 360 twice, and I got a positive and a negative one? Okay. Any other questions? So you can sit and add 360 all day long, subtract 360 all day long. Okay, let's move on to the unit circle. So the unit circle, you guys, couple of things to know. Today we're just going to learn how to use the unit circle, and then after that I will teach you how, because you're not going to be able to have this on an ACT or anything, obviously, right? Or so I'll give you a blank unit circle and I'll teach you how to fill it in so that you can memorize how to do that, and then we'll have a quiz on it later. Today we're just learning how to use it. So a couple of things to know when it comes to using the unit circle. Let me make sure I'm recording, because this recording's being weird. Yep, okay, so we're good. So a couple of things to know. You'll want to write these things down. Unit circles have a radius of 1. So look, from here to here is our radius, right, of our circle. It's 1 unit. So from here to here is our radius of our circle. It's 1 unit. From here to here is the radius of our circle. It's 1 unit. From here to here, it is our radius of 1, so it's 1 unit. Do you understand, everybody? So a couple of things to kind of notice. This point would be, this is our x-axis, right, everybody? So this would be over 1 up 0, this point. Does everybody see where that came from? Do you see how this point right here would be going over 0 on x, but up 1? Do you see where these points are coming from? And then over this way would be negative 1 on x, up 0. So that's where that point comes from. And then this would be over 0 on x, but down negative 1 on the y. So that's where those points come from. And then unit circles are something that we use to calculate exact values of different angles. So these angles, obviously there's other angles, like we could draw in 15 degrees, right? But it works, the unit circle, these are just common angles that you run into. So it works in a 30, 15, 15, 30 pattern. So from here to here I add 30. Then I add 15 to get to 45. Then I add 15 to get to 60. Then I add 30 to get to 90. So it always goes in that order. Add 30, add 15, add 15, add 30. Add 30, add 15, add 15, add 30. Add 30, add 15, add 15, add 30. Does that make sense, everybody, of where those angles are kind of coming from? So it's a 30, 15, 15, 30 rule. And then on the unit circle, we have a bunch of XY points. So look right here. An XY point, XY point, XY point at 60 degrees. At 90 degrees, we have an XY point. At 120 degrees, we have an XY point. At 135, we have an XY point. Does everybody see the XY points on this? No confusion. Now here's what you have to memorize. Cosine of theta is x, sine of theta is y. Cosine is x, sine is y. So a lot of students tend to want to put sine first, because you always think of trig as sine, cosine, tangent. But you have to remember, cosine is x, sine is y. I'm going to say it again. Cosine is x, sine is y. So then we can go through and find sine of cos and cosine of all these xy points, or all these angles, by using the unit circle. Because cosine is x, sine is y. So let's go ahead and use the unit circle to find these exact values. So, everybody, you have your unit circle. It says, find the exact values for sine and cosine of each angle. And then it says, also find the decimal answer. So I'll teach you how to do that. First of all, your calculator has to be in degree mode. So everybody, go to your calculator, hit the mode key. Everybody, hit the mode key at the top. Did everybody find the mode key? Now scroll down where it says radians. We need to change it from radians to degrees. So go over to degrees with your arrow, hit enter. If it's highlighted, you're good. Then hit second quit. Is everybody good? Okay. Awesome. Now, the reason we use the unit circle is so that we can find the exact values, because that's what's appropriate as an answer. We want exact values. So it says, find sine and cosine of angle 150 degrees. So let's find 150 degrees on our unit circle. It's right there. So I have the point square root of 3 over 2, comma 1 over 2. Does everybody see on your unit circle how you have that? Well, we know that cosine is x and sine is y. So cosine of 150 degrees is equal to this exact value, the square root of 3 over 2. Everybody see how I got that? There's our answer. Yeah, negative, yeah, I didn't write the negative in. Negative square root of 3 over 2. Good catch. Any questions? So then our sine of theta. Theta's our angle. So our sine of 150 degrees is equal to 1/2. So our answer is negative square root of 3 over 2 and 1/2. Does everybody see that? Pretty easy, right? That's why the unit circle is awesome. Because we could have gone through, drawn a right triangle, done actual trig. That would have taken us all night and day. You probably don't even remember how to do that. Does everybody see how we did it? Now we want to know the exact values. There's 2 ways of doing it, you guys. Let's all practice it. And this is how you can check your answer. So type in your calculator, cosine of 150 degrees. You get negative 0.87 if we round to 2 decimal places. Now so I typed this piece into my calculator. Well, let's also type this in because it better be equal to that. So now type in your calculator, negative square root of 3, close your parentheses, divided by 2. Did you get the same decimal? Yes, but this is the exact answer. So do you see how you can check to make sure your answers were correct? Okay, sweet. So you can type it in either way. You can type in, so it wants also the decimal answer. So sine of 150 is 0.5. Well, 1/2 is 0.5. So we know we've done it right. So you're like, well, why use the unit circle if we can just get the decimal answer? Because this answer, you'll never, it's not a pretty answer, it's hideous. I promise you on an ACT or on our tests, they want this exact answer. Thus, you use the unit circle. Do you understand what I'm saying? Do I need to do another one? Okay, let's do another one. Negative 330 degrees. Okay, so this one seems to, actually this one, I'm glad that we're doing another one. Okay, so negative 330 degrees. That's going to be a little bit harder. It's somewhere over here, right? It's negative 130, right? So we have to go below. We're going in the direction clockwise, right? Okay, so to figure out where I'm going, what's equal to negative 130? Well, let's think about it. Couldn't we find the coterminal angle? Because doesn't it land on the same line? So I'm going to add 360, so I know exactly where I'm landing on my unit circle. So negative 130 plus 360, that's the same thing as 230 degrees. Now it's easy to know exactly where I need to go on my unit circle. Do you see why I'm using the positive? Because it's a lot easier than trying to figure out the negative direction of that. So I'm going to go to 230 degrees, which is right. Negative 130 plus 360. That's not on my unit circle, is it? I think I wrote because we can't use our unit circle if it's not on the unit circle. My examples were all supposed to be on the unit circle. So I must have wrote down this wrong. So we need to be 225. So wouldn't it be negative? Right. So let's do that instead. Sorry, I wrote this example down really quick yesterday. So negative 135 plus 360 is positive 225. So that makes it a lot easier. There we go. If not, we can't use our unit circle. So it's positive 225, which is equal to negative 135 degrees. So now I'm going to 225. Now if I went negative 135, it lands in the same spot. So we know we're at the right spot. So then we know that our point is negative square root of 2 over 2 and negative square root of 2 over 2. Cosine is x, sine is y. So you'd say cosine of negative 135 is equal to negative square root of 2 over 2. Is everybody comfortable with that? And then cosine of sine, I'm struggling. Sine of negative 135 is equal to negative square root of 2 over 2. Now you can find the decimal answers. You can either just type it into your calculator or type that into your calculator. I personally think it's quick to just go cosine of negative 135, hit enter. So that's equal to negative 0.71. So that's equal to negative 0.71. All right, questions on how to do this? You all understood why I added 360, right? So I could just use the positive. It's a lot easier to make sure I didn't end up in the wrong spot when trying to go in the negative direction. Okay, awesome. Do 42 through 54.